Hi guys, so this is part 3 of lesson 2 covalent bonding, and in this lesson we are talking about dative covalent bonding. Now the word dative is also sometimes replaced with the word coordinate covalent bonding, and in modern times it is preferred to talk about this type of bond as a coordinate covalent bond. Now, you might wonder now, what do we mean with dative covalent bonding? I thought you said there was only a polar and a non-polar covalent bond, and now you come with another thing. Okay, so just keep calm. So a dative covalent bond is a covalent bond in which both electrons come from the same atom. Now, when will this happen? Well, this can only happen if the other atom has an empty valence shell. So, in other words, we have two criteria for the formation of a dative covalent bond. We need an empty valence shell on the one atom, and we need a lone pair of electrons on the other one. Or if it's not an empty valence shell, then there should at least be subshells that are empty. Okay, so this is important. A dative covalent bond forms when a lone pair of electrons from one atom is shared with another atom which has an empty orbital in its outermost energy level. So empty orbital is subshell, energy level is shell. Okay, so the first example that we are going to look at is the formation of the ammonium ion. So ammonium, and students often confuse ammonia and ammonium. Ammonia is a molecule NH3, ammonium is an ion NH4 plus. So how does this ion NH4 plus form? Now, when we have an ammonia molecule which has a lone pair of electrons, and we have a hydrogen ion which has an empty orbital, what can happen? That hydrogen ion can bond with the ammonia molecule in what we call a dative covalent bond. So both those electrons in that bonding pair there comes only from the nitrogen atom, and the hydrogen ion that bonded didn't contribute anything to this relationship. Now, guys, I just want to indicate that when we draw Lewis diagrams for dative covalent bonds and for ions, we will put them in square brackets with the charge on the outside. So just make sure that when you represent these ions, you represent them as such. So it's important, like I said, that you remember the lone pair of electrons of nitrogen's atom fills the empty orbital of the hydrogen ion. So this sentence over here is positive. And the overall positive charge from the ammonium ion is actually because it accepted a positive hydrogen ion. Now, if we were to draw the Cooper diagram, you will indicate that dative covalent bond or the coordinate covalent bond with an arrow pointing from the atom that shares its electrons with the one that has the empty shell. And here you will see the square brackets with the charge correctly indicated as it should be. Okay, guys, so now it is your turn to attempt exercise 6.